Okay, so we were talking about smell and how it's kind of mysterious. Not exactly sure. We know it works on molecules. Okay, so in this person's nose, you can see a blue circle that I superimposed. This picture is from our textbook, except for the blue circle that I put right inside of her nostril. Okay, so we've got this set of olfactory receptors that process the molecules associated with smell. We have this little pit in our nose that processes not smell, but other molecules. Every mammal in the world has a little pit in their nose that processes the pheromones of the other members of their species. It's called a vomeronasal organ, VNO, because let's be honest. And it detects pheromones. Every mammal species has one. And for the longest time, the claim was the thing that makes us different from any other mammal is that we don't have a VNO. We don't operate on pheromones. Now, I don't know where people got that idea, because if you just look inside people's noses, you can see this pit that is clearly in the same basic spot as every other animal's VNO. So once somebody finally acknowledged that the VNO exists, then it brought up the issue of why? What does it do for humans? We know for other creatures, other mammals, they process pheromones that allow them to know whether the other members of their species are, fertile, or already pregnant, or are friend or foe, things like that. So what does it do for humans? Well, now we have to, accept the fact that it's possible that humans emit pheromones. I think it's pretty much a given now. Humans emit pheromones. Everybody seems to agree to that humans emit pheromones. But what do they do? What do they mean? How do we process them? Okay, I'm going to tell you about some research that's kind of interesting, and you've got to love being a psychologist when you hear this research. And maybe some of you will convert after you're done with this and go, man, that does sound like a fun profession. But one study used men who, for 2 nights in a row, would take a bath using scent-free soap, and they weren't allowed to use any deodorant or cologne, but then they put on this clean white t-shirt that had been washed with unscented soap, so everything's unscented to start with. And the man puts on the t-shirt and he sleeps in it. And then the next night he does the same process, takes a shower and everything, puts the same shirt back on for a second night of sleep, because we want to get it nice and embedded with his pheromones. The theory is that pheromones are secreted most heavily from apocrine glands that are housed in our armpits, in our groin, and around our nipples. So a t-shirt makes good sense because we're hitting 2 of the spots where we think apocrine glands will secrete the fluid that contains pheromones. So the men got clean, put on the t-shirt, slept in it for 2 nights in a row, put it into a plastic Ziploc baggie, and brought it to the lab. Then they had female volunteers who smelled the t-shirts while they still were in the plastic bags. Like all the chemicals would still be in the bag, right? So the women stuck their faces in the bag and took a deep breath. Now the thing about pheromones is that they don't smell like anything. They don't activate your smell receptors. They activate your VNO. So any smell that was occurring was being activated by the olfactory bulb, and that had to do with body odor, and that's bacterial colonies on our skin, stuff like that, whatever. But instead, the VNO was getting activated by the pheromones, and so women would smell the bags full of t-shirt, and then they would rate the t-shirts on attractiveness, sexiness, and intensity. And what they found is that the women found the t-shirts of the men who were separately rated as the most physically attractive as the t-shirts that were the sexiest and most intense. They also rated them for how they made them feel, and the women tended to rate the more attractive men's t-shirts as more made them feel warmer and things like that. So we have some indication that women can kind of rate the genetic fitness of a man based on cues from his pheromones. Now on the flip side, there was another psychologist who did a, so that was called the smelly t-shirt study. That's a fun one. Then we have on the flip side a psychologist who studied the tips that strippers made based on their stage of ovulation. And his hypothesis was that women who are ovulating will give off pheromones indicating their fertility, and that when you're in a non-ovulatory portion of your cycle, or if you're on the pill, you won't give off these pheromones. And he further hypothesized that men detecting these pheromones of fertility would find the women more attractive, and in the form of, in the study of strippers, would indicate that level of attraction by giving higher tips. And that's exactly what he found. He found that the women who were ovulating earned way more in tips than they did when they weren't ovulating, and way more in tips than their cohorts who weren't ovulating, or their cohorts who were on the pill, which suppresses ovulation. So it kind of suggests that in part, maybe the men are picking up pheromones of fertility, and that makes the women seem more attractive. There are other issues that go along with being in ovulation that, if you're interested, I teach human sexuality. So, but that's, one possible interpretation is that the men were picking up on the women's level of fertility and found them more attractive when they were fertile. Okay, so those are the kinds of interesting studies that are going on in psychology, trying to figure out whether we have a VNO that can pick up pheromones and whether we secrete pheromones. That doesn't even get into some really interesting issues about why women who live together will develop menstrual synchrony. They'll start menstruating together. And actually, the woman who's the most dominant tends to be the first one to start menstruating in the group each month. Interesting stuff. Human sexuality, if you're interested in it. So anyway. Okay, now this last sense, you might say, wait a minute, we've already covered 5 senses, and I was always taught when I was a kid that there are only 5 senses. Well, this is a 6th sense, and it's your awareness of where your body is in space, and whether you're moving or not, and how you're moving. It's a vestibular sense that detects your position of your head and your position of your body in space. I love these guys and the ability to do these postures. I mean, oh my gosh. Your vestibular sense includes your sense of balance. So maintaining an upright position while you're riding a bike or while you're walking, these kinds of things, walking down a narrow curb or something, you have to rely on your vestibular sense. The semicircular canals, which are attached to your cochlea, are in charge of your awareness of your head position. So you know how the cochlea was filled with fluid. See these tubes that are coming off the end that really make this look like a snail, right? Because you've got these tubes, one which is in the forward-backward plane of space, the other one that's going on the side-to-side plane of space, and the other one that's going in the horizontal plane of space. They're also fluid-filled. But they're fluid-filled like a carpenter's level is, so that there's a bubble in the fluid. And the position of that bubble helps your brain to figure out where your head is in space. So as you tilt your head and the water shifts in those semicircular canals, a little message gets sent back to your brain to let you know that you've tilted your head. If you're walking, the fluid in those semicircular canals is jolting every time your foot hits the ground. And so your semicircular canals know that you're walking. And then, of course, you feed in the information from your eyes as the world is going past your eyes, and your brain concludes, I must be walking, I must be moving. Now, your brain was designed for you to walk or at most jog through the world, right? And your brain can compensate for cues that have to do with walking and jogging. Where your brain gets a little messed up is when you're riding in a car or on a boat or in a plane or something like that, and your semicircular canals may not be sending off a message of movement because maybe things aren't moving that much in the car, so you're just sort of maybe getting a general vibration. But then everything in your eyes is rushing past you, and it gives the impression that you're moving really fast, but your semicircular canals give the impression you're not moving at all. That disparity, the difference in the message from your eyes and your ears, makes your brain really confused. And when your brain's confused, for whatever reason, it comes to the conclusion that the solution is to throw up. So the root of motion sickness really tracks back to that mismatch between what your eyes and your ears are telling you, what your eyes and your semicircular canals are telling you. It's one of the reasons why, if you're on a boat, they tell you to go on the deck and look at the horizon. That'll make you feel better. Partly it's because your eyes can see the horizon. There's also that wind gives you a third piece of information. So if you've got eyes telling you that you're moving and wind telling you that you're moving, your semicircular canals kind of get overridden. And then your brain goes, well, I must be moving, right? So it's important for, 2 out of 3, we got to have a majority rules kind of interpretation. So if you can give, like if you're getting car sick, opening the window oftentimes helps. Because now I have my eyes telling me I'm moving, I got the wind going past my face, now I feel better. So that mismatch is what triggers motion sickness. How about something else that you may or may not have ever experienced, which is the bed spins if you've been drinking. Anytime that you're dehydrated, the fluid in your semicircular canals will go down. And so if you've ever been sick and gotten a little dizzy, and I'm not talking about blood pressure drop dizzy, which is where you feel like you're going to pass out, but I'm talking about like your sense of balance is off because you're sick. It's because you get dehydrated. You might have gotten dehydrated after vigorous exercise too, and same kind of effect might have happened. But when you've been drinking, when the alcohol is a diuretic, so it absorbs some of the fluid out of your body, depletes the semicircular canals. When you lay down, your heartbeat is adequate to move the fluid in your semicircular canals so that you get this sensation of you must be walking, because it's this rhythmic pulsing sensation in your semicircular canals. But you're not walking. Your eyes are staring at your ceiling. And so your brain starts to go, make the ceiling seem like it's swirling around to account for why your ears are getting the sensation that you're moving. Now, if you've ever heard the old-fashioned cure, which is put your foot on the ground, it's kind of right in the sense that if you keep moving your feet, it'll make your brain think, okay, so my foot's moving, the water in my semicircular canals is moving, there we got that 2 out of 3 is telling me I'm moving, and then so I must be moving. So if you have the bed spins, you got to repeatedly stomp your foot if you want it to actually override your brain's inclination to just throw up. If you got the bed spins, you're a little intoxicated anyway. You might as well just go ahead and throw up and get it over with. You'll feel better in the morning. Anyway, so that, and same thing with spinny rides. If you go on a spinny ride, the fluid in your semicircular canals gets pushed outwards by centrifugal force, and then when you get off the ride, it settles sort of like like water in a bathtub after you've gotten out of the water. It sort of all has to settle back down into stillness. And that movement of the water in your semicircular canals, yet you're standing still now that you're off the ride, makes your brain think, I better throw up. I don't know why throw up's the solution every time, but it's always the solution. Now, the thing about your senses is, I think we're getting that impression from my discussion of balance, is that your senses interact with each other. So you need to have feedback from your eyes, your ears, your touch receptors for you to determine whether you're really moving or not. Things like that. Let's talk about taste for a second, because you've probably been sick and eaten something and realized it didn't taste very good when you were sick because you were congested, and so you're like, all my coffee tastes like, in my case, is sweet and sour, because coffee's naturally bitter and sour, and then I always add a lot of sugar. So when I drink it when I'm stuffed up, it just tastes like bitter, sour, sweet, not good, right? Because I'm not smelling the coffee. Smell plus taste, and then of course also sight. You're looking at it and you know what you're expecting it to be, right? And then the texture also in your mouth, all combine to determine the flavor that you actually experience. So your tongue is in charge of taste, right? And it has those 5 tastes that it can detect. Your nose is going to be in charge of smell, and it has really hundreds of things that it can recognize. And of course your eyes are going to look at it and go, it's red, it's probably going to taste like cherry or watermelon or strawberry or maybe apple, possibly. Usually apple's green though, so I'm not sure. And then you taste it and it actually doesn't taste like any of those red normal flavors, and you're like, what is that? It's confusing, right? The taste may not clear up what your expectation from sight had been. There were some Skittles that came out a couple of summers ago that were mystery color flavors, and the color didn't match the normal flavor, and it was a trip trying to figure out what they were. And then of course there's texture. So on your project list is an assignment where you can get a willing volunteer to eat pieces of apple, pieces of pear, pieces of onion, and pieces of potato while blindfolded and their noses plugged. So we're getting rid of the smell and the sight, and then we want to see if they can tell which is which just by taste. But there's one other thing that's going on in that project, which is texture. So you may discover that your participant can tell the onion from the other things because onions are kind of slippery, or they can tell the pear from the other things because it's more grainy. The one that usually gets them the most is apple and potato because they're both sort of equally starchy, and they can't tell the difference between those kind of things. But so sensory interaction explains how we get the richness of flavor that we really experience, and not just the 4 tastes that were possible through our tongues. All right, let's go ahead and stop here, and we'll come back and talk about perception in the next segment.